We're continuing with logarithms today, specifically going from the Ben form that you see at the top here, b to the e equals n, to the logarithmic form, where we have the exponent equals a log, base b of n. So e is for the exponent, b is for the base, n is for the number. We have lots of examples today, and the examples should follow right along with the homework or the classwork that we're going to do tomorrow. So let's get started. I might leave some of these blank for you to try. I always recommend when you're comfortable, hit pause on your computer or your tablet or your phone and try the next one on your own, even if I don't say it. So let's get started. We're rewriting each of these in logarithmic form, which means I'm giving them in exponential form. So all I need to identify, remember, I'm not going to write this every time. I want to know what the base is, what the exponent is, and what the number is that they equal. Base, exponent, and number. So looking at this first question, the base is 2. The exponent is 4, and the number that they equal, 2 to the 4th, is 16. So we're going to take our base exponent number now and rewrite 2 to the 4th equals 16 in logarithmic form. We know we take the exponent equals the log. The base is a subscript and 16. So log of 16 base 2 or log base 2 of 16. Is how you say that. Let's do a couple more. Number 2, rewriting it, find the exponent. It equals the log base 5 of 125. Maybe pause and try the rest of these on your own. So in each case, I wrote the exponent equals the log, and I found the base of the number. This second last one right here, since it's base 10, you could try this one on your calculator if you want. You simply type in the log of 0.1, because the plain old log is automatically base 10. And after you hit enter, you should see that that is indeed equal to -1. Okay? Let's look at section D. Section D says rewrite in exponential form. Okay, so now we're going the other way. Again, we still need to know what here is the base, what here in this log equation is the exponent, and what in our log equation is the number. So the base, of course, is that subscript 10, it's right there. The exponent is what the log equals, and the number is log of the number, so in this case it's 100. So if we piece this back together as an exponential equation, we have 10 our base to the second power, our exponent, equals 100. So I do 10 squared equals 100. And we know that's true. Let's do number 2. The base is, if you said 5, you're correct. The exponent is, if you said 3, you're correct. And 5 to the third should equal our number, 125. Stop your video and try the next 3 on your own. Next 3 on your own. Base, exponent equals number. Base, exponent equals number. Base, exponent equals number. Whoops, disappeared. Sorry about that. There we go. Really should get that fixed. All right. Let's go on to the next section. So practice now. Do you know how I can rewrite b to the e equals n? The exponent equals the log base b of n. So what we're doing in section E, it says evaluate each expression. So you're going to find a value or get an answer using the exponential logarithmic relationship. That's this that I'm talking about up here, the bend to log. So in some cases, it'll be necessary to take a log expression and change it to exponential so that we can figure out the answer. So 1a and b and c and d are all log expressions, everything here. So we want to say we know this is going to equal an exponent. They all will. This is going to equal an exponent, this is going to equal an exponent, and this is going to equal an exponent. Actually, I'm going to save that one to put the rule. So let's rewrite them. 3 is the base to what exponent equals 3. Now just solve that. I could have also put x's here, as in that's my answer, that's my answer, that's my answer, since we're evaluating. So in that case, it would look like 3 to the x equals 3. And I think we all know that answer is 1. 3 to the first is 3. So let's rewrite all of these in exponential form. Base to the exponent equals the number. Whoops, I'm backing up there. Well, 10 to what power is 10? And it's 1 again. How about 1c? Base to the exponent equals number. 1 again. So look at each of these 3 cases that we just did here. And we had log base 3 of 3, log base 10 of 10, log base 4 of 4. So in general, if you have log base b of b, in other words, your base matches your number, it will equal 1. So that's a rule. You can put a little cloud around that. 3 matches 3, 10 matches 10, 4 matches 4. All right, let's move on. Number 2, we have 5 times log base 7 of 7. Oh, they match. So we know if they match, that equals 1. So this is just 5 times 1 equals 5. So we're evaluating, finding a value. Number 3. So looking down the row here, none of the rest of these match. So we're going to set these equal to an exponent or a value, and we're going to rewrite them. So number 3, base to the exponent equals the number. And 6 to what power is 216? Try a couple on your calculator. You might know that 216 is 6 to the third power, so x equals 3. Let's do number 4. Base to the exponent equals the number. You got to really pull the information from the last chapter out. 1/2 is the same as 2 to the -1, and that's to the x. And so that equals 2 to the 1. So I did 2 to the -1 to the x equals 2 to the 1. And so then I can drop my bases and say -x is 1, so x is -1. Or you might just know from here that if I put -1 as the exponent, I get 2. Number 5. Number 5 has a 3 multiplying out front. So I'm actually going to take and figure out the logarithm value first. Log base 4, so 4 to what exponent equals 1/16? And then I'm going to multiply that answer by 3. I'm going to do this in 2 steps. So first, just the logarithm. Logs are exponents, so I rewrote it as an exponent. 4 to the x equals 1/16. Do you know the answer to this? Well, 4 to the x equals 1/16 is the same as 4 to the -2. So that would mean that that logarithm, x is -2. So this logarithm is -2. Now don't forget, we're going to multiply our answer by 3. And we get -6. And if you're curious on these, we can't quite put these strange bases into our calculator just yet. I will show you how to do that. I'm sure Mrs. Johnson will show you how to do that. But we're not quite ready for that yet. So don't try these on your calculator by hitting the log button, because hitting the log button on your calculator is automatically base 10. And that'll come up in another section as well. Let's keep going. Got some good questions here. We've got a log times another log. So we need to evaluate these separately. 3 to what power gives you 81 will be the answer to the first part. And 2, I'm going to use a different variable, to what power gives you 16. So remember, I'm just rewriting my logs in Ben form so that I can figure out the part that's missing. So here, I know that 3 to the 4th is 81, so that first part equals 4. And here with n, I know that 2 to the 4th equals 16. So this logarithm is equal to 4, and this logarithm is equal to 4, and 4 times 4 is 16. That was a good one. All right, there's 4 more to do here. Let's try a couple more together and then go on to the next section. Number 8 looks good. And number 10. So this one I'm going to have 6 times the value of this logarithm. So I have this logarithm to evaluate. And on the bottom, I have this logarithm to evaluate. And I will multiply by 6. So I have 6 times something over something. Let's go figure those 2 out. The first one, rewrite it in Ben form. 5 to what power equals 25? That answer is 2. Rewrite this one in Ben form. 2 to what power equals 1/2? Hopefully you said -1. And so when we work this out, 6 times 2 divided by -1 is -12. And number 10. So we have 5 times a logarithm. We highlight the logarithms here. We're going to figure out the value of this logarithm. We have another value to figure out for this logarithm, and a third logarithm to figure out down here. I don't know why it does that. Okay. So for the first logarithm, I'm going to be multiplying it by 5. And then I'm going to add the second logarithm and subtract the third logarithm. So I'm going to do these above since I have some room. You could do them below, I guess. Yeah, let's do them below. So the first one, 3 to what power, I'll use A, is 27. Let's go through and change them all. Log base 2 is 64. So the base is 2. I have an exponent that I need equals 64. And the third one, log base 6 of 216. 6 to what exponent is 216. So the answers to each of these sections we'll put in the parentheses. Here, we know that an exponent of 3 on 3 will give us 27, so that answer is 3. This evaluates to 3. For the second one, 2 to what power is 64? If you said 6, you were correct. And the third one, 6 to what power? 6 squared is 36. 6 cubed is 216. So that last part is 3. And we have 15 plus 6 minus 3, or 21 minus 3, or 18. All right, so there's a couple blank there. If you want to try them and check them in class, you can do that. Or we can do them together in class. Let me know if you need them. Let's see what section F has. Solve each equation using that relationship, our Ben to log. And this time we have all log equations. All right, let's start with 1. So we're going to rewrite in exponential form, which is Ben form. So our base is 8. 8. The exponent is 3. And that should equal x. Now you could go ahead and do that on your calculator if you'd like. 64 times 8 is what I'm doing on the board. 8 to the third power is 512 if my arithmetic is correct. Number 2, let's set it up. Base to the exponent equals the number. So you either know this or you're going to start trying powers of 2. 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th. Try something. And it should be 2 to the 5th is 32. Let's skip and do the evens. Number 4, base is b to the third equals 27. So here we have to pull out some information from our last chapter. We need to see, we can take b to the third power to the 1/3 power.
Please excuse this interruption, but will those students attending the business law field trip to the Erie County Holding Center please report to the horseshoe at this time? Once again, those students attending the business law field trip to the Erie County Holding Center, please report to the horseshoe at this time. Thank you.
So if we raise both sides to the 1/3 power, then I just get b, and I get 3. b equals 3. And that was a strategy from section 7.5 or 7.6. All right, 1, 2, 4, let's do 6. Base is 5. Exponent, -2 equals y. So we just want to say y equals 5 to the -2 is 1/5 squared, or 1/25. I'd rather see fractions than decimals. Number 8, base is 100 to the exponent is -1/2 should equal x. So here we have x equals 100 to the -1/2. Remember, is 2 rules. The negative is 1 rule that flips the 100, and the half is a second rule that takes a square root. So I will have 1/100 to the positive half, or 1 over the square root of 100, or 1/10. Doesn't look right there. Okay. In number 9, we just have a function f of x, that's the same as y equals log base 3 of 81. Y equals log base 3 of 81. So remember I said earlier, you can't put this in your calculator just yet because it's a base 3. What we can do is change it to Ben form, base to the y exponent equals 81. And then you may know, or start trying, that 3, let's see, 3 squared. I'm going to write these down for you guys. 3 to the first, of course, is 3. 3 squared is 9. 3 cubed is 27. 3 to the 4th is, there it is, 81. So that exponent is 4. Okay, let's see. I think that's it. There's a couple there for you to try. Many there for you to try. But the bottom line is going back and forth from Ben form to log form or log form to Ben form so that you can set the question up in order to answer it. Have a great weekend. I'll see you Monday.